comma z bar for a three-dimensional case. So if you are dealing with a two-dimensional problem, your aim is to find x bar comma y bar. And if a composite figure is given like this, let us say there is a rectangle and there is a square, sorry, there is a triangle, and over that there is a semicircle also. So all that you have to do is designate each subpart as individual areas. So this is area number 1, area number 2, and area number 3. And now the formula for your centroid is built as the summation of all areas multiplied by the individual centroids, which are depicted by x star and y star, divided by the summation of all areas or the total area. So in this case, if I want to find out what is the x star value of this rectangle, the individual centroid of the rectangle is here. So the distance of this centroid from the y-axis is x1 star. Similarly, this is the centroid of the triangle, and this distance from the y-axis is your x2 star, and this is the individual centroid of your semicircle. So this distance measured from the y-axis is x3 star. So individually, you set out to find the values of x1 star, x2 star, and x3 star. And once you have found these individual centroids of the individual areas, you simply apply this formula as x bar is equal to a1 x1 star plus a2 x2 star plus a3 x3 star whole divided by a1 plus a2. This was the methodology that we adopted for finding the centroid of composite sections. But now, let us deal with a new problem. For example, I give you a figure like this. The origin is given, and an area that looks like the combination of two ellipses or the combination of two parabola or hyperbola. It could be anything. This is given. Now, this is not a standard area, and especially if it is made out of a combination like this, it becomes very difficult. For example, if I give you a circle and then I intercept it with a parabola, and I ask you to find out the centroid of the common area between these two, then it becomes a real problem, because this is not a standard area. A circle is a standard structure. A parabola is a standard figure, but it is not enclosed. In other words, parabola एक enclosed figure ना होने के कारण इसका खुद का तो area होता ही नहीं. And if I ask you to find out the centroid of such complicated figures, or you don't even have to go into so much complications, I will simply give you a question like this. Look at this figure. See this one. The origin is given. They drew a straight line and then they drew a parabola, and now they want to find out the centroid of the area enclosed between the straight line and the parabola. So if such questions arise, and again look at another example. Now in this case, the origin is given, a parabola is taken, and they have drawn a vertical line at a distance of 6 units. So they have enclosed the parabola from here. and they are asking you to find the centroid of this area. So these type of questions become a real problem for you, and these problems cannot be solved by the equation that you learned till now. Or in other words, if you try to apply this equation, x bar is equal to a1 into x1 star plus a2 into x2 star, because there are no different areas here. There is a smooth area, single area, about which you have no idea at all. There is no standard shape of this area. You have never seen an area like this, and there is no standard formula for a1. Forget about the centroid of this figure. If I simply ask you what is the area of this figure, you cannot find a formula for that. For that, you have to use integration. So now we bring in the concept of integration for solving such questions. And surprisingly, if you look at the formula, you will find that it is almost exactly similar to what you have already learned. Let us see how they are similar to each other. Take an example of a rectangle. This is the origin. The size of the rectangle is given as 3 meters in length, 2 meters in width. It is also given that this corner of the rectangle is 1 meter from y-axis and 1 meter from x-axis. Now, without using any concept or any formula, can anybody simply tell me the value of x bar by bar?
2.5 or 2?
2.5.
It is
2.5 and 2.
2.5 and 2. This is the correct answer. Okay. Now, what we will do is we will apply the concept of integration to find the centroid, and we will see whether the answer that we obtain is matching with the correct answer, 2.5 comma 2. Now the concept of integration is like this. The task at hand is one area is given to you. Okay, in this case it is a standard area and there is actually no need to apply the concept of integration, but we are learning the process. So we will start with a simple area of a rectangle. Now what I am doing is I took a small strip of area and I have intelligently selected this strip of area in such a way so that it covers the entire width of the rectangle. See, this entire width of the rectangle is covered. The thickness of the strip is so small that it is called as infinitesimally small. Infinitesimally small means ये इतना छोटा है कि ये आप एक सिंगल लाइन के जैसे भी एज्यूम कर सकते हो. इसकी थिकनेस जो है dx, this dx is actually tending to 0. इतना छोटा है, ठीक है. Now tell me what is the area of this strip. I will call the small area of this strip as dA. So please tell me what is the area of this strip. If the strip has a width of dx and a height of 2, what is the area?
So integration of idea.
2D.
I am asking dA only. Small area of this shaded area.
2dx.
It will be 2dx. Because this shaded area is in the form of a rectangle only. And this infinitesimally thin rectangle has a width of dx and a height of 2. So the area, the infinitesimally small area of the rectangle is 2dx. Okay. Now, if I consider this as a rectangle, I will draw another figure without the shading. This is the infinitesimally small rectangle. Now, considering this small rectangle as an individual area, can you tell me what is the location of the centroid of this rectangle? Everybody knows that the centroid will be located at the center of this rectangle. And if I say that this strip was selected at a distance of x from the y-axis, then what is the location of the centroid as x bar. X bar कितना है? What is the location of the centroid? It will
x plus dx upon 2.
okay. It will be x plus dx upon 2, but since dx tends to 0, you can eliminate this term. So, whenever you take a very small strip or very thin strip, and if somebody asks you what is the location of the center of this strip, so you just put a dot there and you measure the x distance from the y-axis, and you simply say that x bar is nothing but x. You ignore the thickness dx. Okay. Now tell me what is y bar. This is the same figure. Please look at this figure and tell me what is the y bar value of this strip alone. And actually, I
2.
should not be writing this as x bar and y bar. I should be writing this as x star.
The 2.
Y star is
So
2.
2.
Very good. Because the center of this strip will be nothing but the center of this height. And this height is 2. So this is 1 and this is 1. So 1 plus 1, 2. So y star is 2. So if you ask me what is the value of x star, y star, when do we use a star instead of bar? X bar is the centroid of whole area. And x star is the centroid of individual area. So if I have taken the individual area as a thin strip, how many individual areas do I have in order to cover the complete rectangle? I will take a thin strip here, then I will take a thin strip in the vicinity again. Again, I will take a thin strip. And if all the thin strips are having thickness dx, 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 how many thin strips do you think are required to fill up the complete rectangle? Please give an answer. How many thin strips are required? Each thin strip has a thickness dx which tends to 0. How many strips? बताइए. Anybody? The width of the rectangle is given as 3 and each strip is of thickness dx and
The
dx.
1 2. The limit 1 2 3 and dx
No,
integration.
I'm asking how many strips are required. How many strips? Give me a number. Not the formula for integration. I need how many strips. The correct answer is infinite. भाई अगर आपके स्ट्रिप की कोई फाइनाइट डिस्टेंस होती, ये dx जो है, ये dx टेंड्स टू 0 होने की बजाय अगर ये dx इक्वल टू 0.001 कुछ होती, then the number of strips would simply be 3 divided by 0.001. This is the number of strips. But when dx tends to 0, the actual number of strips that are required to fill up the rectangle are infinite. So basically, what we are going to do is, for finding x bar, we try to apply this formula. X is equal to, the first area is dA multiplied by x1 star. The second area is also dA multiplied by x2 star plus dA into x3 star and so on till infinity, and whole divided by dA plus dA plus dA, how many times? Till infinity. So whenever a case like this comes up, instead of using a summation sign, we have been using the summation sign till now. Summation of all dA x star whole divided by summation of dA. Instead of using this formula, we replace this summation with an integration symbol. This is what is given in your notes. So x bar by integration is found by this formula. But now, with the discussion that we had right now, you know that this formula is nothing different from this formula which you have already been learning. These are the same things. The only thing is the dA values are very, very small, very near to zero, and there are infinite number of dA values. So instead of using the summation, we use an integration. Okay. So by using this concept, what I am going to show you is how to solve the centroid of a rectangle. Now look very carefully. By looking at this one example, you will learn the concept and then we will apply it to more complicated concepts. And if at any point of time you do not understand what I am doing, please interrupt me and ask me. I gave you a rectangle like this. This was 3, this was 2. These distances are 1 and 1. And you already know that the centroid is at x bar comma y bar as given by you was 2.5 comma 2. This is the correct answer that we are expecting. Okay. Now, what I do is I have taken a strip. The thickness of the strip is dx, and this strip I have taken at a random distance of x. This is what you have to do. Take any distance x at which the strip is selected. Okay. So first of all, write down what is the area of the disk. dA is 2dx. This is the height 2. This is the thickness dx. So the area dA is 2dx. What is x star for this area? X star for this area is the distance at which the strip is located from the y-axis, because the centroid of the strip will be somewhere around here. See, okay, and we are trying to find the x distance of the centroid. And since this is a vertical strip, the x distance of this centroid will be nothing but the distance of the strip itself from the y-axis. So x star is x. Now, what is the formula, integration formula for me? I know that x bar can be obtained for the complete rectangle. I want to find this centroid. Okay, so this centroid, according to the integration formula, will be obtained by integral of x star dA whole divided by integral d. Now let us analyze these things. Integration will be carried out from which value to which value. Okay, first of all, let us substitute these values. I will keep the integral like this only. I have not substituted the limits. X star is x. So I put x here. dA is 2 into dx. So multiplied by 2 dx. Whole divided by integral of dA. Now, please tell me, can I say that the integral of dA is simply the whole area of the rectangle? Anybody? क्या
Yes,
मुझे
sir.
Yes, sir.
क्या मुझे ये इंटीग्रल डीए में लिमिट विमिट लगा करके फॉर्मेलिटी करने की जरूरत है क्या? भाई नीचे तो वैसे भी टोटल एरिया आता है ना, तो इंटीग्रल डीए का मतलब है इस पूरे रेक्टेंगल का एरिया, एंड दैट इज इक्वल टू 3 मल्टीप्लाइड बाय 2 इक्वल टू 6. So I will simply replace this with 6. So I will rub it off and put a 6 here. Okay. So eventually what I get is x bar can be obtained as integral of 2x dx divided by 6. This is my answer. Okay. Now the thing is, what is the limit of this integration? See, I will be putting strip
Sir, 1 to 3.
1 to
3.
no, wrong. What is the x coordinate of this rectangle at this point?
Sir, 1 to 4.
Yes, this is 4. See, the length of the rectangle itself is 3 and there is a distance of 1 from the y-axis. So this extreme edge of the rectangle will be at coordinate 4 and the leftmost extreme will be at coordinate 1. So this is 1 and this is 4. And you have to vary your integration from this corner to this corner. So the limit of integration will be 1 to 4. Now quickly solve this integration and give me the answer. Can I say this is 2 x square by 2, the limits of 1 to 4 whole divided by 6. Let us simplify it. 2 and 6 cancel out. So this will be 16 by 2
8, sir.
minus 1 by 2 whole divided by 3. Is it correct? Simple
Yes,
integration
sir.
कर रहा हूँ मैं.
Yes, sir.
ठीक है. So this will be 15 by 2 into 3. That is 5 by 2. That is
2.5.
2.5. Is it correct or not? X bar
Yes,
is
sir.
2.5. See,
Yes, sir.
the integration formula gives you the same answer. Now let us find out the value of y bar with the same concept. Y bar, according to the formula, is integral y star into dA whole divided by integral dA. This is the formula for y bar. Now let us find out what is the value of y star. Let us draw the figure here itself. This was your strip. You took the strip at a distance of x from the y-axis, and this is the centroid of the strip itself. The individual area centroid is here. Now what is the vertical distance of this centroid from the x-axis? This is your y star. What is this value?
2.
This is 2, because the height of the rectangle itself is 2. The space below the rectangle is 1, and you know that the center of the strip will be at half value of 2. So this is 1. So y star is 1 plus 1, 2. And if you keep on taking different strips from left to right, do you think that y star will change, or will y star remain the same for all the strips? I take a strip here, I take a strip here,
तो सेम रहेगा सर.
same
तो
रहेगा.
सेम रहेगा.
तो y star अभी इस इक्वेशन में कांस्टेंट है. ठीक है. So now I substitute y bar is equal to integral y star is always 2 multiplied by dA. What is the value of dA? It is dx multiplied by
2D.
2. So it is 2 dx. So this is 2 dx. dA was 2 dx, y star was 2. Now this whole divided by the total area of the rectangle, and that is 3 multiplied by 2, that is 6. So eventually I get my y bar as integral 4 dx divided by 6. What are the limits? Again, the area is made to travel from the leftmost edge to the rightmost edge. So what is the coordinate of x here? This is 1. What is the coordinate of x here? This is 4. So again the limits are 1 to 4. Now let us solve this quickly. 4 dx will give you 4x. 1 to 4 upon 6. So that means 4 multiplied by 4 minus 1 divided by 6, which is equal to 2. Do you get it?
Yes, sir.
And this is your answer. Y bar was equal to 2.
So
So this is the concept of using integration for solving or finding the centroid of any area. Now, for a rectangle or a triangle, this is not a very big deal. Actually, you are wasting your time by using the method of integration. Because for rectangles and triangles, you have already memorized the location of the centroid, and you do not need the method of integration because these are standard areas. The problems which appear like these are the areas where you have to actually find the solution by using the integration method. So now let us try to solve this problem. Okay, I will just clear my screen. Let us start. Now look at the problem. Find the coordinates of center of gravity of shaded area between the parabola y is equal to x square by 4 and the straight line y is equal to x as shown in figure. So there are two lines and you have to find the area that is enclosed between these two, and apart from that you have to find the centroid of this. So the centroid of this area will be somewhere around here. This is what you have to locate. Okay, so again, by using the integration method, what I will do is I construct the origin, I take the straight line, this is y is equal to x, I take the parabola 2. So this parabola is going to intersect this line at some point. Can you find out what will be the coordinate of this intersection point? Because this is important. Because as you can see, this is the strip of area that we are going to select. See, this is the strip of area. And this strip of area has to be traveled, or it has to be made to travel from this point to this point, this vertical line. So from here to here, this vertical strip will be traveled. So in order to find out what is the total distance of travel, you need the coordinate of this intersection point. So this is the formula for your parabola. This is the formula for your straight line. How do you find the intersection? Can anybody tell me? I just want the x value. I don't even need the y value. I just want the x value. How?
y की जगह x रख देंगे.
Yes. इसको
4
solve
sir,
करना है आपको.
0,4.
See, you have got two equations. One equation is y equal to x, and the other parabola equation is y equal to x square by 4.
4 sir.
Okay, so all you have to do in order to find the x location of this intersection point is to put these two equal to each other. Since both are equal to y, so I will simply put x equal to x square. This will go 1 x will cancel out. So what is the value of x? This 4 will go and get multiplied with 1, and x is equal to 4. So what I get is the area has to be traveled from x equal to 0 to x equal to 4. And then I take a strip. Now see, whenever you take an infinitesimally thin strip, and this strip has to be intelligently selected parallel to the y-axis. Or on the other hand, if you do not like the y-axis, you could even take it parallel to the x-axis like this. This is also possible. But in that case, the area will travel along the y direction. So it will travel from 0 to this coordinate of y, and you have to find the y coordinate of the intersection point. So both approaches will give you the same answer. But since we already have a figure with a vertical area, let us follow that thing. So we are having a vertical area. Now see what I'm going to do. Now for all purposes, whenever you take a strip, the thickness, if it is along the x direction, you take it as dx. If the thickness, if you had taken a horizontal strip, then the thickness would be taken as dy. But since the strip is vertical, you take the thickness as dx. And again, you have to take it at a random distance of x. Now, in all practical sense, this thin strip of area that you have selected, actually, if enlarged and seen, will look like this. The top edge will be a slanted line. The bottom edge would be a curve. This is how this strip is going to look. But you have to take it as a rectangle. Why? Because this thickness is so small that eventually it will not matter whether this edge is slanted and this edge is a part of a parabola. It will not matter at all because this thickness is extremely small. So in all practical purposes, no matter how the figure looks like, you always take this infinitesimal area as the area of a rectangle. This is one thing that you have to remember. So now what I want to know is the location of x bar and y bar. And I know that x bar is simply given by the formula integration of x star multiplied by dA divided by integral of dA. This is the standard formula that I have to remember, that you have to remember for x bar. So now let us find the individual values. What is x bar? What is dA? If these two quantities are known to you, then the only thing that remains for you is to solve this question by integration. And integration you have to practice. If your integration formulae are not up to the mark, then you please go back to your mathematics textbooks of your 12th class and please refresh the methods of integration because that is very important. Okay, so what I have to do is I have to find dA first. So tell me, how will I find dA? dA means the area of this shaded rectangle. Now, if I have to find the area of this shaded rectangle, what I need is, I need this height as y2 and this height as y1. And eventually, if I subtract y1 from y2, I will get the height of the rectangle. This is the height of the rectangle. And obviously the thickness is dx. So my area, as I know from the logic that was explained here, is nothing but height multiplied by dx. But my height is equal to y2 minus y1. Now what I have to do is find out what will be the y2 value and what will be the y1 value. Now let us draw a fresh figure to understand these features. This is the situation. This is y1. This is y2. Now see, y1 and y2 are both obtained by the intercept x. Okay. So all I have to do is put the value of x coordinate as x in the equation of the parabola. So I get this point. and put the value of x equal to x in the equation of the straight line. So I get y2. Now the equation of straight line is y equal to x. The equation of parabola is y is equal to x square. Sorry, x square by 4. So now, looking at this figure, tell me what is the value of y1 or what is the formula for y1. For y1, I have to obtain this coordinate. So in the equation of parabola, y is given as x square by 4. And instead of x, if I substitute this x, because this is the random distance x we have taken, so there will be no change at all. So y will be simply x square by 4. So this is y1, and y2 will be, substitute this x in the formula of the straight line, because this y2 is lying on the straight line. And again, since we are substituting x only, so substitution of x in place of x will make no difference. So y2 will be x. And what is the height? The height is given as the difference of y2 and y1. So it is x minus x squared by 4. This is the height. Now once the height is obtained, this is the rectangular piece that we have selected. The height you have obtained as x minus x squared by 4. The thickness is dx. So what is dA? Can I say that dA is height, which is x minus x squared by 4, multiplied by thickness, that is dx. H into dx. H into dx. This is dA. So we have obtained the equation for dA. Did you understand this part or not? Please tell me. Those who are listening carefully and trying to understand, ये समझ
Yes,
में आई
sir.
क्या? ये clear
Yes,
हो गया
sir.
Yes,
ना?
sir.
Yes,
Okay.
sir.
So dA has been obtained, and this is the formula we wanted to apply for x bar. So dA is ready. Now we want to find out the value of x star. So look at this formula again. Sorry, look at this image. This is the strip. The centroid will be located at the center of this rectangle. We are talking about the centroid of the small rectangle only, not the centroid of the complete area. The centroid of the small rectangle is somewhere around here. And if the distance at which you have taken the strip is x, what is the location of x star? Anybody? X
X.
star means,
X, correct.
बिल्कुल सही, x is the correct answer. X star का मतलब क्या है? X star is the x distance of the centroid. And since the strip is so thin that its thickness can be nearly ignored, so the centroid is, although it is dx by 2 distance away from x, but we are ignoring this dx by 2 distance and we consider the centroid to be at x only. So x star is x. So now you have dA and you have x star. And now we are ready to apply this formula. This formula says integrate x star into dA divided by integral of dA will give you the value of x bar. So let us apply this. X star is x, dA is this, x minus x square by 4, whole divided by dA. So dA is this, we repeat here. Now tell me, what are the limits of integration? Look at this figure. Or rather, okay, look at this figure. We have identified this distance as 4 and this as 0. So you know that if a vertical strip is taken here, this vertical strip will be started at 0 and this will travel all the way
4.
up to this distance. So the limits of integration are 0 to
0.
4. So now in this equation, we apply the limits of integration as 0 to 4. 0 to, and now you solve it. Now I'm not going to solve this integration because this is a very simple problem of integration. You guys solve it and check whether you get this answer or not. This is the answer. X bar should come out to be equal to 2. Now let us calibrate the value of y bar. You just remember the formula. It is integral y star dA upon integral dA. So nothing much is changing in the previous equation. See, instead of x star, we simply replace it by y star to get y bar. dA is same. The denominator is same. Everything is same. The only thing is you have to replace your x star by a y star. Now, in order to find the y star value, let us go back to our figure. This is the strip that you have taken. This is the origin. This distance is x. And at the distance of x, you already identified the two heights at which the rectangle is trapped between y1 and y2. So what was y1? y1 is x square by 4, y2 is x. Okay, so y1 is x square by 4 and y2 is x. And now the centroid of this strip is here. In other words, I can say that if the bottom edge of the rectangle is y1, the upper edge of the rectangle is y2, then the centroid should be at which location? It should be at the center of the top and bottom edge. That means, can I say that if this height is my y star, y star is, what is y star? Y star is the location of the centroid of your area from the x-axis. Y star. And since y star has to be or must be located at the center of this rectangle, which has its upper limit as y2 and lower limit as y1, then can I say that this y star will nothing be but the average of y1 and y2? Can I say that or not? Okay, sorry, one minute. I think you are not seeing. I'm really sorry, you are not getting the image. Now please look here once again. I have drawn this image. This is the rectangle. This is y1. This is y2. I want to locate the value of y star because I want to find out y bar. And y bar is integral y star dA upon integral dA. The only difference is instead of x star, you have replaced it a y star to get y bar. dA is the same, integral dA at the denominator is the same. Okay. We draw the figure again. This is the strip that you have taken, and y star is the location of this centroid from the x-axis. So this is y star. And we already know that the top end of this rectangle is y2, bottom end of the rectangle is y1. So can I say that since we are talking about the centroid of this rectangle, it will be at the center of the rectangle. And we already know that the rectangle is between y1 and y2. So the center or y star will be located at the average of y1 and y2. So can I say that y star is y1 plus y2 by 2? Anybody?
Yes, sir.
Okay. So since y1 is x square by 4, y2 is x, can I say
सर नहीं
that
समझ
y,
में आया।
ये नहीं समझ में आया? एक बार ये
हम्म।
फिगर वापस से बना देता हूँ, अब आपको समझ में आ जाएगा पक्का। दिस इज योर रेक्टेंगल, ये y2 है, ये y1 है, और रेक्टेंगल का सेंट्रॉइड जो है वो रेक्टेंगल के सेंटर में मिलेगा मुझे, तो ये वाई स्टार है। देखिए वाई स्टार क्या होता है, आपके इंडिविजुअल एरिया के सेंट्रॉइड का वाई डिस्टेंस एक्स एक्सिस। ये तो समझ में आ गया, यहां तक आपको समझ में आया कि ये बताओ।
यस सर।
अब देखो, चूंकि रेक्टेंगल का टॉप एंड y2 है और बॉटम एंड y1 है, और y स्टार जो है वो इन दोनों के बीच में होना चाहिए, तो y स्टार जो है ये y1 और y2 का एवरेज हुआ कि नहीं हुआ?
हाँ सर।
है ना? अब y1 और
यस।
y2 आपको ऑलरेडी पता है, y1 आपका एक्स स्क्वायर बाय 4 है, y2 आपका x है, तो इसको सब्स्टिट्यूट कर दो।
हाँ।
सो y स्टार बिकम्स x square by 4, which is y1 plus x whole divided by 2। ठीक है, तो ये y स्टार हो गया। अब इस y स्टार के साथ में आपको dA मल्टीप्लाई करना है। dA की वैल्यू क्या थी आपकी? dA was calculated as this।
x minus x square by 4 into
ओके,
dx।
सो dA is, एक फ्रेश पेज ले लेते हैं अपन। dA is x minus x square by 4 dx. This is dA. And what we just found out, y star is equal to half of x plus x square by 4. And your y bar is given by integral y star dA by integral 2. And the limits of integration will remain the same. That means 0 to 4. This was identified as 4, right? 4 था ना? 4, yes. So integral 0 to 4, integral 0. Now y star is known to you, dA is known to you. Substitute these values here and find the value of y bar. Again, this is a problem of simple integration. We will not discuss this, and I am leaving it for you to do. The answer should be 8 by 5. So please check the implementation of this. I hope you have understood how we calculated the centroid for a complicated figure like this using the concept of integration. This question is again left for you to solve, and I have taken all the questions as solved problems. See, this problem, if you want to refer, then you already have RK Bansal book, and this is a solved example. Go to problem 9.7. You will find the complete solution there. But I have explained it how it is done. The concept was explained. Similarly, for this question, problem number 9.6 from Archibald. And finding the centroid of volumes is exactly the same as finding the centroid of flat areas. The only difference being we are talking about a volume. So in your formulae, the first change that will occur is, since we have three dimensions, x direction, y direction, and z direction, because it is every volume is a three-dimensional image. So only x and y will not suffice. You need the third dimension z also. And the only difference is, look at the formula. Instead of x bar into dA for a flat area, you are using x bar into dV, where dV is the small volume. Y bar is y star into dV. Now, what I want you to do is go to practice problems, problem number 9.12 and 9.13 from Archibald, and try to understand these questions. The concept is exactly the same as you have studied today, using the method of integration to find. 9.12 and 9.13 are this question. This is 9.12, this problem. This is 9.13. That means you have to find the centroid of a cone and the centroid of a hemisphere. So please refer the book and try to understand it. And if you do not understand it, if there is some problem, then in your free time on any day, including Sundays, you can give me a call and ask me to come to a personal Google Meet, और वो पर्सनल गूगल मीट में आपको आपकी जो भी प्रॉब्लम होगी वो मैं सॉल्व करके समझाऊंगा. बट दिस टॉपिक आई एम फिनिशिंग हियर, ऑल्दो इट माइट सीम कि थोड़ा सा रश करके खत्म किया है, लेकिन अभी अपना बहुत सारा सिलेबस बचा हुआ है, तो इसीलिए अपन एक एक टॉपिक पे दो दो लेक्चर ज़्यादा डिवोट नहीं कर सकते. एंड सिंस द कॉन्सेप्ट ऑफ इंटीग्रेशन इज ऑलरेडी, आप लोगों ने फॉर्मूले सारे रट रखे हैं, तो इट इज एक्सपेक्टेड कि आपको एक बार मेथड समझा दिया तो इंटीग्रेशन वाला मेथड आप अपने आप अब यहाँ से पिकअप कर सकते हैं. तो इस प्रॉब्लम शीट में जो जो प्रॉब्लम यहाँ पे दे रखा है, दिस वन एंड टू प्रॉब्लम्स ऑफ वॉल्यूम इंटीग्रेशन, ये चार प्रॉब्लम्स आप लोग पढ़ के समझने की कोशिश करें, और अगर ना समझ में आए तो गिव मी अ कॉल बिफोर 8 PM ऑन एनी डे. ठीक है
सर,
हाँ
सर आगे क्या आपने पीडीएफ सेंड कर रखी है?
बिल्कुल बिल्कुल, आर के बंसल आपके पास में मैंने सेंड कर रखा है. जो क्लासरूम का जो आपका ऐप है उसमें आप पुरानी पोस्ट देखिए एक बार. आपको मैंने 4 किताबें शेयर कर रखी है. आर के बंसल है, भाभी कट्टी है, और एक डीपी शर्मा जी की किताब है, और एक कुर्मी की किताब है. ये 4 किताबें मैंने आपको शेयर कर रखी है. आपके
सर
क्लास
डेट याद है क्या, कुछ अप्रोक्सीमेट डेट?
आपके क्लास में किसी से पूछो भाई, आपकी क्लास में
9 जुलाई 9.
अच्छा,
आपको चारों किताबें मिल जाएंगी, डाउनलोड करो और इसमें से आप थोड़ा सा इसको सॉल्व करने की कोशिश करो. ठीक है,
ठीक है सर.
चलो ओके. बिफोर गोइंग आई विल टेक योर अटेंडेंस.